this is the solution to tutorial 4, question 1. So the first question is asking how do we express the producer's problem as a constrained optimization problem, assuming she wants to minimize cost. So to minimize, so the cost function is, so the minimum cost function, so we put min subject to capital and labor. So the cost function is cost is equal to R times K, so R times capital, plus W times labor. So that's a cost function. And to minimize this, we've got to set it subject to the production function. So the production function is given, and that is given by Q is equal to K to the power of 1/3 plus, times L to the power of 2/3. And then to minimize this, we've got to set it up as a Lagrangian. So we take the Lagrangian, and then we set that is equal to RK plus WL plus lambda times quantity minus, so we bring that bit over to the other side, minus QK to the power of 1/3 L to the power of 2/3. And that is how you set it up as a cost minimization problem.
Okay, so the second question asks us to find the input demand functions. So to find the input demand functions, we first find the partial derivative of the Lagrangian with first respect to K, which is capital, then labor, then lambda. So we start by partial deriving this to capital. So the first one is, so you get R, then minus, because it's minus, 1/3, because you times 1/3, so that comes to the front, and times lambda times capital minus 2/3, because it's 1/3 minus 1, and then times labor over 2/3. And then next we do labor, oh wait, and then that's equal to 0. And then next we do labor, which is W minus 2/3, because that also comes to the front, you times it, times lambda times capital 1 to the power of 1/3, and then times labor to the power of 1 to the power of 1/3, because it's minus 1 from 2/3. And then next we do the partial derivative of lambda, which is just what's in the bracket. So it's Q minus K to the power of 1/3 times lambda to the power of 2/3. Next we find the optimum decision rule, which is marginal product of capital over marginal product of labor is equal to R over W. And you can see that this is the marginal product of capital, and this is the marginal product of labor. And we also have R over here and W over here. So all we do is we take these two to the other side, and then we divide the marginal product of labor, which is this, by that, or the other way around. Yeah. So following the optimal decision rule, which is the marginal product of capital over marginal product of labor, which is rewritten out here. So we've taken the R over W to the other side. So to start simplifying this, I'll start here. So 1/3 divided by 2/3 is equal to 3/6, because you flip these and times them with fractions. And then that is equal to 1/2. So we can start doing here, so 1/2. And then the two lambdas cancel each other out. And then to calculate these, we can rearrange these. So it's K to the power of 1/3 times K to the over 1. Both are over 1, 2/3. Because it's a minus, you can make it so it becomes a fraction, or if it's 1/, just flip it. So when you times these together, it equals 1/K times 1, because 1/3 times 2/3 is 1. So we can put that here. And then next, to do the labor, we do the same thing. So it's L 2 over 3. And then you can rearrange this one to become L 1 over 3. And that's going to become L to the power of 1. We put times L to the power of 1. And that's going to simplify to 1 over half. Okay, so that comes to, and then adding these into, is R over W is equal to 1/2 times L over K. So next, we just want to solve for labour, because that's the easiest one to get. So we just multiply 2K by both sides. So it's R over W, and then E times 2K, so it's 2 times capital, is equal to labour. Then we solve for labour.
So from what Andrew gave us here, L, 2 times K times R all over W, we can substitute it in here. So we get Q equals K to the power of a third multiplied by 2 times K times R over W all to the power of 2/3. So firstly we simplify by bringing in the power here. So we still have K to the power of a third, and that's multiplied by 2 to the power of 2/3, multiplied by K to the power of 2/3, multiplied by R to the power of 2/3, all over W to the power of 2/3. So firstly, we can bring over W. So we have Q times W to the power of 2/3. And we can also simplify by multiplying into K to the power of a third and multiplying it into K to the power of 2/3. So we have 2 to the power of 2/3 multiplied by K to the power of 1 multiplied by R to the power of 2/3. So then finally we can get K on its own by bringing over the 2 to the power of 2/3 and R to the power of 2/3 over to this side. So we can switch it, and we have K equals Q multiplied by W to the power of 2/3 all over 2 to the power of 2/3 multiplied by R to the power of 2/3. And that is the demand function for capital. So continuing on, we find the capital demand function. We now need to sub it back in here to find the labour demand function. So we have Q equals, summing it in to get Q times W power of 2/3 over 2 to the power of 2/3 times R to the power of 2/3 multiplied by L to the power of 2/3. So, and that's to the power of a third. And firstly, we can simplify and bring in the power. So we have Q to the power of a third by W to the power of 2/9, because we multiply the top by the top and the bottom by the bottom. So 1 times 2 is 2, 3 times 3 is 9, and it's the same on the bottom. So we have 2 to the power of 2/9 times R to the power of 2/9 multiplied by L to the power of 2/3. So we can bring over the bottom to give us Q times 2 to the power of 2/9 multiplied by R to the power of 2/9 equals Q to the power of a third multiplied by W to the power of 2/9 multiplied by L to the power of 2/3. So we want to make L the subject, so we bring over Q and W to give us Q, and we can subtract from the power here. So 1 minus a third is Q to the power of 2/3 multiplied by Q2 to the power of 2/9 multiplied by R to the power of 2/9 all over W to the power of 2/9 equals L to the power of 2/3. So now to leave L completely on its own, we bring over the power, we divide each one of the powers here, so we get Q on its own multiplied by 2 to the power of a third multiplied by R to the power of a third all over W to the power of a third. And that is the labour demand function.
Right, finally, when we solve for lambda, we look back at our first order derivative with respect to capital here, and we end up with that, and then what we do is we substitute L, which we know equals that from previous workings, substitute that value in there, and then we solve for lambda. So we end up getting r equals 1 over 3 k to the negative 2 over 3, and then L comes up, so 2k r over w to the power of 2 over 3 times lambda. So to simplify, to bring this, we put the power in, and to do that, we just times that by, they're all to the power of 1 at the moment, so we just times them together, so we get 2 over 3. So r is equal to 1 over 3 k to the negative 2 over 3 times 2 to the power of 2 over 3 k to the power of 2 over 3 r to the power of 2 over 3 all over w to the power of 2 over 3 times lambda. And then to simplify this, we can see that k here is to the power of negative 2 over 3, and k here is positive 2 over 3, so that just becomes k to the power of 0, and anything to the power of 0 is 1. So we end up with r is equal to 1 over 3 times this without k in it. So we get 2 to the power of 2 over 3 r to the power of 2 over 3 over 3 w to the power of 2 over 3 times lambda. And then to bring this over, we lambda can come to the top there because it's times y. To bring this over, we times both sides by 3w to the power of 2 over 3, so we end up getting r times 3w to the power of 2 over 3 is equal to 2 to the power of 2 over 3 r to the power of 2 over 3 lambda. And then we just divide by both sides by this bit here to isolate lambda. So we get lambda is equal to 3rw to the power of 2 over 3 over 2 to the power of 2 over 3r to the 2 over 3. And we can see that we've got two r's here, so it's a division, so r to the power of 1 minus r to the power of 2 over 3, since they're the same thing. So we've got lambda is equal to 3r to the power of 1 over 3 w to 2 over 3 all over 2 to the power of 2 over 3. And that's your value for lambda. Finally, part 3 of the question is you're asked to derive the cost function. So if you remember, that's our cost function, but now we have values for k and l, which are those. So we just substitute them in for k and l and then simplify. So cost is equal to r times q w to 2 over 3 all over r to 2 over 3, 2 to 2 over 3, and then it's plus w times q r 1 to the power of 1 over 3, 2 to the power of 1 over 3 over w to the 1 over 3. So simplifying this, we can see that r and r there, that's times by, so that's the power of 1, and that's that's 1 over r to the power of 2 over 3, so that would become r to the power of 1 over 3. So we would end up with r to the power, so we'd end up with q r to the power of 1 over 3 w to the power of 2 over 3 all over 2 to the power of 2 over 3 plus w, and you've got it on the bottom here, so when you times it by that, that's w to the power of 1, so that would become w to the power of 2 over 3, so we take away that bit. So we've got q r to the power of 1 over 3 w to the power of 2 over 3, and then 2 to the power of 1 over 3. And then from this we can see that this bit and this bit are the same, so it becomes this part add this part times by this part, simplify it, so it becomes 1 over 2 to the power of 2 over 3 plus 2 to the power of 1 over 3 times our q r to 1 over 3 w to the 2 over 3. So to get this part, which is a bit tricky, we come up to the top, we express that as a fraction, so we get 1 over 2 to the power of 2 over 3 plus 2 to the power of 1 over 3 times 2 to the power of 2 over 3 over 2 to the power of 2 over 3 when we express that as a fraction. And then for this, we simply end up since we've got the bottom denominator, we add them together, and that times that becomes 2 to the power of 1, so we end up with 1 over 2 to the power of 2 over 3 plus 2 to the power of 1, which is just 2, over 2 to the power of 2 over 3, so we end up getting 3 over 2 to the power of 2 over 3, which is our answer for that. And then finally, that would become the cost function. This cost function is equal to 3 over 2 to the power of 2 over 3 times q r to the 1 over 3 w to the power of 2 over 3. There we go. That's the cost function. Finally, we're asked to work out the average cost and marginal cost. So the average cost of this, we just divide it all by quantity, so Q. So the average cost is equal to 3 over 2 to the power of 2 over 3 times, take away, if it's divided by Q, Q just becomes, Q over Q is 1, so it just becomes R to the power of 1 over 3, W to the power of 2 over 3. And that's the average cost. Finally, the marginal cost is equal to the derivative of the cost function with respect to Q. So if it's respect to Q, the rest is all constant. So we end up with 3 over 2 to the power of 2 over 3, and then no Q because that's what it's respect to. And then we get R to the 1 over 3 and W to the 2 over 3 because they're all constant terms in that. And then we can see here that this is correct, as marginal cost is equal to average cost, and that is correct when you're at cost minimalization. Marginal cost should be equal to average cost, which is also equal to lambda, if you can remember what lambda was equal to earlier. And that's the solution to tutorial 4, question 1.